So now let us take up the next method of preparing alcohols. This is from Grignard reagents. First of all, what is a Grignard reagent? Grignard reagent has a general formula RMGX, where X, it can be a chloride, bromide or iodide, whereas R, it can be an alkyl group or it can be an aryl group. So it can be an alkyl or an aryl group. So this is what our RMGX looks like. And what exactly do we have in this Grignard reagent? R is basically a nucleophilic center, and thus Grignard reagent is a source of nucleophilic carbon. Now let us take up the first part here. What we can do is we can take a Grignard reagent like this and we can react it with a carbonyl compound, which can be either an aldehyde or a ketone. So let us call this as an aldehyde or ketone. How would this reaction exactly occur? This is partially negative and this is partially positive. You know that the carbonyl group is generally has the carbon which is partially positive. So now you have R going here and oxygen moving out there. So what do you get? You get, I can put a single arrow. What you can get is C O minus MgX plus, and you have R here. This is an intermediate, and this intermediate is hydrolyzed using a dilute acid. Hydrolysis would produce C, R and OH. This is going to be an alcohol, and this here is called hydrolysis. So this is the basic reaction of how a Grignard reagent may react with aldehyde or ketone to form an alcohol. The first step that you see here, it is a nucleophilic addition step in which a nucleophilic R from Grignard reagent adds onto the partially positive carbon of an aldehyde or a ketone. Now let us take up some very specific examples and find out what type of alcohols get formed. So now let us take up the first example. Here we've taken methyl magnesium bromide, and this is methanol. Now here you know that this is partially negative, and so the first step would be a nucleophilic attack here, and pi bond collapses onto oxygen. So the intermediate which is formed is going to be CH3 CH2 O minus MgBr plus, and this undergoes hydrolysis. Hydrolysis is H plus and water, and this would give us CH3 CH2 OH and plus MgXOH. This here is ethanol which is formed, and it is a primary alcohol. So methanol produces ethanol, which is a primary alcohol. One thing you have to know that if you want to increase the carbon skeleton of any aldehyde and convert it into an alcohol simultaneously, you may use such reactions. The second reaction is the one in which there is once again the nucleophilic attack on partially positive carbon. This would give us structure in which you have O minus, MgBr plus, and this further undergoes hydrolysis to give propane 2-ol. This is a secondary alcohol. So now we can generalize one thing, that methanol is the only aldehyde. Methanol is the only aldehyde here which can produce primary alcohol. Rest of the aldehydes are able to produce secondary alcohol. Let us find out what happens with ketones. So let us take up we take the same Grignard reagent, methyl magnesium bromide, and we allow it to react with a ketone. So the first step, the nucleophilic attack, would give us CH3C, CH3, CH3, O minus, MgBr plus, intermediate, and this upon hydrolysis. Hydrolysis is H plus and H2O. This would give us CH3C, CH3, CH3, OH plus MgBr OH. This is 2,2 2-methyl propane 2-ol, and this is a tertiary alcohol. So ketones produce tertiary alcohols. This is most important thing. All aldehydes except methanol, they produce secondary alcohols, and methanol produces primary alcohol. So methanol gives you primary alcohol. Aldehydes except methanol produce secondary alcohols, and all ketones, they always produce tertiary alcohol. So this is about the reaction of Grignard reagent with aldehydes or ketones producing different types of alcohols. The next that we would take up is how Grignard reagents react with acid chlorides or esters. So let us find out how Grignard reagents react with acid chlorides. CH3, let's say first of all I'm taking up Grignard, CH3, MgBr, same thing, partially negative, plus CH3, C double bond O and Cl. Unlike aldehydes and ketones, acid chloride, this is called ethanoyl chloride. It has a very good leaving group. And so the first step here would be nucleophilic addition on partially positive carbon. And you have CH3, C, CH3, O, Cl minus Br plus. This is the intermediate. Whenever you have a leaving group, the pi bond gets reformed and the leaving group leaves the substrate. So you get CH3, C, double bond O and CH3 minus MgBr and Cl. This is a ketone, so if they write excess of Grignard, the reaction further continues, and if they write only 1 mole of Grignard, then the reaction stops here. This is a ketone. If more of Grignard is present, then the next step takes place. In the next step, we take up once again CH3 MgBr. The same thing, CH3 adds on to the partially positive carbon, the nucleophilic attack, and we end up in getting CH3 C, CH3 CH3 O MgBr. This is the intermediate, and it undergoes hydrolysis and it gives you a tertiary alcohol. Sorry. So even acid chlorides, they can produce tertiary alcohols. Next, we would take up the reaction of Grignard with an ester. So let us consider the reaction of Grignard reagent every time this is methyl magnesium bromide reacting with ethyl ethanoate. Let us find out how would the reaction take place. The first step is a nucleophilic addition, and so we get CH3 C, CH3 O minus MgBr plus OCH to CH3. This would result into CH3 C double bond O and CH3 plus MgBr OCH to CH3. If Grignard is taken in excess, then one more nucleophilic attack. I am taking the Grignard once again, CH3 MgBr, and there is going to be a nucleophilic attack on the partially positive carbon. We end up in getting CH3C, CH3, CH3 O MgBr. This is going to be an intermediate salt, and this finally upon hydrolysis would give us a tertiary alcohol. Thus, even esters, they generally produce tertiary alcohols as the products when they are made to react with Grignard. As you can see here, what is the name of this alcohol here? The name is, this is 1, 2 and 3, 2-methyl propane 2 all. So this is 2-methyl propane 2 all. So this is how Grignard reagents, they react with esters.